Hi, my name is Percy Arlequet. Today I'm going to discuss two major pitfalls of using recursion and how we can overcome these challenges to write efficient and reliable code. The first pitfall is the stack overflow. Uh, every time a recursive function calls itself, the computer pushes a new stack frame onto the call stack to store local variables and the return address. If the recursion goes too deep, either because the input is too large or there is no proper base case, the program will consume all the allocated stack memory and crash. To overcome this, we can use interaction instead of recursion. Loops like for or will use a constant amount of memory, regardless of the number of repetitions. Another technique is the tail call optimization, where the computer reuses the current stack frame if the recursive call is the last action in the function. And the second pitfall is redundant calculations. In many recursive problems, like calculating the Fibonacci sequence or the climbing stairs problem, uh, the algorithm branches out and solves the same subproblems over and over again. And this leads to exponential time complexity, which makes the program extremely slow as the input size increases. And to overcome this, we can solve this using memorization by using a data structure like a dictionary to store the results of each unique recursive call. We can simply look up the answer if we encounter the same input again. This transforms an exponential O of 3 elevated n problem into a linear O of m solution. In my recent project, adding a memoization dictionary was the key to pacing tests that were previously tidying up. And in conclusion, while recursion while recursion is a powerful and elegant tool, it requires careful management of memory and efficiency. By choosing interaction when depth is an issue and memorization when subproblems overlap, we can write much more robust software. And well, that's all. Thank you for your time.